In this video, I'm building a neural network that can recognize handwritten digits. And you might think that neural networks are way too complicated and that you need to spend years studying math and other complex topics before you can even start. But that's not true. You can just pick a project, start coding, and figure things out along the way. Step by step, you'll solve problems and learn everything you need. Plus, there are already tons of powerful libraries that can make it easy to create neural networks without worrying about all the complicated math. In this video, there won't be much coding, because my goal isn't for you to just copy my code. I want to give you the knowledge and tools to build your own neural network by yourself. Before we start coding, we need to understand what a neural network actually is, and you probably imagine it looks like this. But in reality, this is just a visual representation. A neural network is actually this. Yeah, it looks terrifying, right? Let's get rid of that and replace it with something simpler. Much better, right? You can think of a neural network as just a mathematical function. You feed it input data, it processes it, and spits out an output. The magic happens inside the function. But here's a problem. Functions take numbers as input, while we need our neural network to recognize images. So it's very important for us to understand how we can feed an image to a neural network. Technically, everything in our world can be represented using numbers. An image is just data about its pixels. Each pixel is a combination of 3 numbers, red, green, and blue values, ranging from 0 to 255. For this project, we're using 28 by 28 pixel images, and if we break that down, we get 2,352 numbers to feed into our neural network. And it's way too much. To optimize this, we will use grayscale images instead. Here, each pixel is just one number from 0 to 255, where 0 is black and 255 is white. That reduces the input data to 784 numbers, making the process much more efficient. But this is just the input data. The next important step is to think about the structure of our neural network. We have 784 input numbers, so our neural network will need 784 input neurons. At the output, we need to recognize digits from 0 to 9, which gives us 10 output neurons. Between the input and output layers, we need hidden layers. This determines how complex the task our neural network can solve. You can think of them as the IQ of the neural network. For this task, 2 hidden layers with 512 neurons each should be more than enough. But these numbers aren't fixed. You can experiment with them to improve accuracy. Now that we have our structure, let's move on to the most important part, training the neural network. Remember, a neural network is just a mathematical function. But how does a function learn? Well, our function has a huge number of parameters. Every connection between neurons is a parameter that can be adjusted to improve accuracy. These connections are called weights. Training a neural network means finding the right set of weights so that it produces correct predictions. Here's the training process. The neural network makes a prediction. We compare it to the correct answer, and then we calculate how wrong it was. And then we adjust the weights to reduce the error. And we repeat that until the accuracy is high enough or we run out of training cycles. And now we have the basic information about neural networks, and the next step is coding. To write our neural network, we'll need Python, PyTorch, the MNIST dataset, a little bit of luck, PyTorch's official documentation and tutorials. And of course, all links will be in the pinned comment. And here is the step-by-step coding process. We import all that we need, prepare training and test datasets plus data loaders, build the neural network, define hyperparameters, create the training function, create the testing function, set up the training loop, and save the model. And I know, it looks like a lot. But honestly, this entire code is just following PyTorch's official documentation. And if you want to really understand the code, just take a few minutes to read the docs. Now that we've coded everything, the only thing left is to train the model and see how well it performs. I trained my neural network for 100 epochs, and it achieved more than 90% accuracy. That's not bad at all. Now let's take it a step further. We can draw our own digits in Paint and feed them into the trained neural network. And to my surprise, it got everything right. In this video, you'll learn the core concepts of neural networks. I intentionally skipped the heavy math and complex theory because you don't need it to get started. Once you begin experimenting and writing code, you will naturally start exploring these concepts on your own, and who knows, you might even find them interesting. But right now, just start coding, and if you get stuck or don't know how to do something, Google it or ask ChatGPT, and step by step you will dive deeper into the world of neural networks. And of course, all the necessary links are in the pinned comment, and if you want to see more videos like this, then hit that like button, subscribe, and see you